All right, so here we go. We've done systems of two linear equations. So now we're going to look at application problems involving systems of two linear equations, okay? So same idea. We're either going to solve it using substitution or elimination or addition, right? But we first have to take a word problem and pull the valuable information to come up with our two equations. And then once we have our two equations, we solve like always, okay? All right, so let's go ahead and jump into an example. Let's look at this first one, which says that we want to write a systems of equations that accurately represents each scenario and then solve for the indicated value, okay, or values. There might be more than one answer. So this one says an air conditioning company counted 56 invoices. At the end of the month, they charge $450 for a new installation and $75 for a service call. The total dollar amount of the invoices was $9,450. How many installations and service calls did the company perform? So when we have a system of two equations, there's two unknowns. And they're telling us here we're looking for the number of installations and the number of service calls. So those are the two things that this problem is going to represent, right? So let's go back and see what we can find out about them. We want to know how these things are related. We know they each have costs, and then it looks like we might have a total cost and things like that. So let's go back and read it again. It says an air conditioning company counted 56 invoices. Okay, so that is going to be a total, right? I'm going to write here, this is a total. 56 invoices. So that means that's going to include all of the installations and all of the service calls, right, at the end of the month. So we're looking at two separate things. We're looking at new installations, and you know what, let's just label that one in for new installations, okay? And then service calls, which I'll label C. I'm not using an S because S's tend to start looking like fives. We don't want to make mistakes. All right, so we have new installations and service calls, and we ended up with 56 total invoices. So that's going to give us our first equation. We know that the number of new installations plus the number of service calls is going to total 56, right? So there's our first equation. Now we need to know how else they're related. And the other relationship they gave us was the total dollar amount of the invoices. Okay, so this is another total amount. Okay, now the way that we get the total is by the cost of each thing. So we know that a new installation is $450. So for every new installation, I'm charging $450. This is a per new installation. Same thing with the $75 service call fee. For every service call, it's going to charge $75. So I'm going to write this as new installations are $450 a piece. So I'm going to do 450 in plus, right, because that's how we calculate it, $450 times each new installation plus $75 for each service call. And we ended up with a total dollar amount of $9,450. Okay, so this is my system of equations. Is everybody kind of okay with how we got there? Okay, total invoices is just our calls plus our installations, right? But then to get this dollar amount, we do the price per thing, right, added together. Okay, so now we need to go ahead and solve this. Now I know I did a ton of examples on doing the addition or elimination method in the last video, so I'm going to go ahead and do one with substitution just so that you see a little practice on that one, because this is a really easy one to solve for N or to solve for C, right? I'm going to go ahead and just solve this one for N. So if I solve this for N, all I have to do is move that C to the other side by subtracting. So I'll end up with N is equal to 56 minus C. Okay, so I'm solved this for N. So now I know that N is equal to 56 minus C. So I'm just going to take that 56 minus C and I'm going to plug it in for N in this second equation. So I'm just going to rewrite this second equation, and instead of putting an N, I'm going to put in this quantity that I know is the same thing as N. Okay, so I have 450 times N, which we know is 56 minus C, plus 75C is equal to 9,450. Okay, and now this is something we can go ahead and solve because all we have is C's, right? So we distribute 450 times 56 gives us 25,200 minus 450 times C is a negative 450 C plus 75C equals 9450. Okay, and then we want to combine our like terms, our C terms here. Okay, so I have 25,200, negative 450 and 75 leaves me with negative 375C is equal to 9,450. And now I need to get this C term isolated. So I'm going to subtract this 25,000 over here. So minus 25,200 minus 25,200 gives us negative 375C is equal to negative 15,750. Okay, same process, right? Just bigger numbers. And then we divide off our negative 375. So when I divide off our negative 375, a negative divided by a negative is going to make this a positive, and it goes in an even number of times, which is 42. Okay, so remember, in terms of our problem, we're not going to write this as an ordered pair unless Newton asks you to. Remember, C is representing our service calls. So this means that they completed 42 invoices, right, for service calls. So if I want to figure out how many of those invoices were new installations, because it does say how many of each did the company perform, I need to plug this back in to find N. Okay, and I can plug it back into one of my original equations, or what I'm going to do is I'm actually going to plug it back into this one because I already have this one solved for N. Okay, so I'm going to go ahead and say N is equal to 56 minus C. We know that C is 42. So when we do 56 minus 42, we end up with 14. Okay, so that means that we had 14 new installations, right? And we had 42 service calls. Okay. Good. So really the process of solving these is exactly identical to what we did in the previous section. The only new thing is that we are having to come up with our equations first. And then once we have our equations, we solve them, right? All right, let's look at another one. This one says the cost of a ticket to the circus is $25 for children and $50 for adults. On a certain day, attendance at the circus is 2,000 and the total gate revenue is 70,000. How many children and how many adults bought tickets? So we know we're talking about children and adults, and we're talking about going to the circus. So we should know how many total children and adults went, right? And we also know how many total dollars were earned during this, right? Or revenue. So here we have our total as being 2,000. That's how many people were in attendance. And then we have 70,000 as our total revenue for that day. Okay. So I am going to label these again. I'm just going to use C for children and A for adults. So if I want to know how many children and adults attended, I don't know that, but I can add them together and I know that it should total 2,000 because that's how many people were at the circus, right? So I'm going to say C plus A is equal to 2,000. And then I'm going to set up an equation that has their costs. So I know that it's $25 for children. So I'm going to charge $25 per kid plus $50 for each adult. So 50 times A, and the total earning of that many people, however many it happens to be, is 70,000. Okay, so here is my system of equations. So I can solve this one very similar to the way I did the last one. I could solve this top equation for C or A and then plug it into the bottom equation. But I'm going to solve this one using elimination because that's my favorite. Okay, so I look at the numbers to see which one's bigger or smaller, right? 25 is a lot smaller than 50, so I'm going to clear C. So remember, in order to get rid of my c terms, they have to be opposites, which means I would have to multiply this top equation by a negative 25, so that this would be a negative 25c, which then would cancel with my positive 25c. So I'm going to multiply this entire first equation by negative 25. Okay, so negative 25 times c is negative 25c. Negative 25 times a is negative 25a. And negative 25 times 2,000 gives me a negative 50,000. Okay, and then we take our second equation and just write it underneath. 25c plus 50a equals 70,000. Okay, I draw my line and I combine straight down. So notice my c terms do cancel. Negative 25 and 50 leaves me with a positive 25a, and negative 50,000 and positive 70,000 leave me with a positive 20,000, right? And then to get a by itself, I just divide off that 25. So I end up with a is equal to an even 800. So remember, in terms of my problem, a is representing the number of adults. So I had 800 adults attend the circus. Okay, so now that I have my answer for a, I need to plug it back in and figure out c. So if I had to choose one of these two to plug it back into, I'm definitely going to pick the first one, right? It's a lot easier to manage. So I'm going to say c plus a equals 2,000. And then I'm plugging in the 800 for a because we've already solved for that. So c plus 800 equals 2,000. And then I move my 800 to the other side to solve for c. So I end up with c is equal to 1,200. Okay, so what this tells me in terms of this problem dealing with the circus, and the number of tickets sold is that we sold 800 adult tickets, right? And we sold 1,200 children tickets. And that is my answer. Okay? Are we kind of okay? Setting up is the hardest part. Solving should not be, right? If you did your homework for the last section. All right, I want to look at 2 more examples, and then I will give y'all some so you can practice, okay? All right, so this one is talking about supplementary angles. So if you move on to trig, you'll go in a lot deeper into supplementary angles, but for the purposes of this class, all we need to know is that supplementary angles add up to 180 degrees. Okay, the sum of their measures always totals 180. So if I add whatever this degree is to whatever B's degree is, that total would be 180, right? Because that's the degree of a straight line. All right, so we want to find what these 2 angles are if one is 28 less than 3 times the other one. Okay, so that's probably the bigger one. That's 3 times as much as the other one. So I'm just going to rewrite A. I'm going to say instead of writing this as A, we could say A is 3 times the other. So the other one is B. So 3 times the other one would be 3B. Okay, but it doesn't say that it's just 3 times the other one. It says it's 28 degrees less than 3 times the other one. So once I have 3 times the other one, I need to make it less than, right, or subtract 28 degrees. Okay, so I'm just rewriting this A angle because it tells us that it's 28 degrees less than 3 times the other one. So I can write this as 3B minus 28. Okay, all right, so now that I've got that worked out, let's see how we can say these are related. The first thing that they tell us is that the sum, which means we're adding them together, is 180 degrees. So that means that A plus B equals 180, right? And then the other relationship we already have written up here. We have written here that A is the same thing as 3B minus 28. So this is my system of equations for this one. Not too bad, right? So the method that I'm going to use to solve this one is definitely substitution because notice the second equation is already solved for A. I already know that A is equal to this quantity right here, right? And if A is equal to that quantity, then I can just plug that quantity into the other equation where I see an A. So I'm going to rewrite this first equation, but instead of writing an A, I'm going to write 3B minus 28, okay? So I have 3B minus 28 that I'm writing instead of this A, plus B equals 180. And then I combine my like terms, so 3B and B gives me a 4B minus 28 is equal to 180, right? And then I move my 28 to the other side by adding. So I end up with 4B is equal to 208. Oops, 208. And then I just divide off my 4. So that tells me that B is equal to 52 degrees. Okay, so we're looking for, it asks to find the two angles, right? So we found one of them. Now we just need to find the other one. So we need to take this 52 and plug it back into one of these. Okay, doesn't matter which one you plug it back into, they're both equally not super hard to plug into. I'm going to go ahead and plug it into the second one just because it's already solved for A. So this says that A is equal to 3B minus 28. We know that B is 52. So A is equal to 3 times 52 minus 28. 3 times 52 is 156. And then I subtract 28 from that, which tells me that A is 128 degrees. Okay, not too bad. So I'm just going to circle those. That's what the two degrees are of my measures that I have here. Let's look at one more, and then I'll let y'all try one. Okay. All right, so down here at the bottom, we have birdseed costs 59 cents per pound, and sunflower seeds cost 89 cents per pound. Angela's pet store wishes to make a 40-pound mixture of birdseed and sunflower seeds that sells for 76 cents per pound. How many pounds of each type of seed should she use? All right, so we are mixing two things, right? It says how many pounds of each type of seed should she use? So notice we have bird seed and we have sunflower seeds. So those are the two things that we're mixing together, right? So I'm going to call bird seed B and sunflower seeds, I don't want to use S, so let's use F. Sunflower, right? Okay, so we're mixing birdseed and sunflower seed, and we should have two type of totals here, right? We know that we want to end up with 40 pounds of this mixture. So we should have one equation that's based just off of the pounds, and then another one that's based off of the cost. So pounds alone, it didn't tell us how much of each one we need, right? That's what we're supposed to figure out. So we're just going to say this means that B pounds of birdseed plus F pounds of sunflower seed should total 40 pounds, right? Because we want to end up with a 40-pound mixture. Then we want to go ahead and multiply the cost. So remember, the cost, we do the amount of pounds times the cost per pound, right? So here we know birdseed is 59 cents per pound. So that means I have 0.459B plus the cost for sunflower seeds, which is 89 cents per pound. So 0.89 times F is equal to. Now on this one, notice they didn't give us a total cost. They didn't say the total cost of this is going to be, you know, $32.59. All they said is the rate that they're going to sell it at. Okay. So the rate, we're going to calculate the same way we did on each of these. We did how much it cost times how much we have of it, right? How much it cost times how much we have of it. So if a total cost is not given, then we have to calculate it. So our total cost here, or our cost of our total mixture, is 76 cents per pound. So 0.76, and how much we have of it, we do know. We should end up with 40 pounds of it. Okay, so again, if the total cost is not given, then we have to write it as the cost per how much we have. Okay, all right, so now we have our system of equations. Now we just need to see how to solve it. Most people do not like working with decimals, but I am not going to shy away from them here, because instead of solving one of these for B or F and then plugging it in, I'm just going to make either the B's or the F's opposites. And here, let's see, we have 59 cents or 89 cents. This is a smaller number, so I'm going to get rid of B. Okay, so to make these opposite, if this one is 0.59, I need this one to be negative 0.59, right? So I'm going to go ahead and multiply this top equation by negative 0.59. Okay, so I'm going to go ahead and rewrite my equations down here once I do this. Okay, so negative 0.59 times B is negative 0.59B. Negative 0.59 times F is negative 0.59F. And then that's going to be equal to 40 times negative 0.59, which comes out to negative 23.6. Okay, so all I did was distribute negative 0.59 to this whole first equation. My second equation stays the same, so I'm just going to write it below here. So I have a positive 0.59B, I have a positive 0.89F, and then I'm going to go ahead and multiply these two numbers on this side just to simplify. 0.76 times 40 gives me 30.4. Okay. All right. So the whole reason I did that is so I can add these two equations together and the B's cancel. The B's are opposites. So I combine down with what I have left. So negative 59 cents plus positive 89 cents leaves me with a positive 30 cents, right? Or 0.3F. Okay. And then when I combine down over here, negative 23.6 and 30.4, combines down to give me a positive 6.8. Okay, and then to solve for F, I just divide off my 0.3, right, or 0.30. So I end up with F is equal to 22.66666, and it just keeps going. Now, I'm not sure how Newton will have you enter it if it comes out not beautiful, if it will have you round it to the nearest tenth of a pound or to the nearest half pound, or if it'll just say round to the nearest pound kind of thing. So that's what I'm going to do. I'm going to go ahead and just write in here, we're going to round to the nearest pound, okay? Round to the nearest pound. So since we're rounding to the nearest pound, since there's a 0.6, I'm just going to go ahead and round this up and say F is 23. Okay. All right, so now when I know what F is, or how many pounds of the sunflower seeds I have, then I need to plug it back in. And obviously I'm going to choose the first equation to plug it back into. So I have B plus F equals 40. So that means B plus 23 equals 40, plugging in my answer for F. And then I just move my 23 over by subtracting. So I have B is equal to 17. So again, in terms of this problem, what we have solved for is that we need 17 pounds of B, which remember represented birdseed. So 17 pounds of birdseed, and 23 pounds of F, which represented sunflower seeds. So sunflower seeds. Okay. Are we kind of okay? It's so scary to do problems that are word problems. Just kidding. Hopefully it's not, right? Just look and see there's got to be two relationships between the two things you're solving for. Either there's a total, or maybe one is a certain amount bigger than the other one, or maybe we can make something out of their rates, out of their costs, out of the amounts, okay? So just look for those relationships. All right, so on the next couple of pages, there are 3 problems for y'all to try. So go ahead and pause the video and try those out. If you have any questions, go ahead and play the video and we'll go over them. Okay. I will make a note on number 2. Number 2 is one that doesn't turn out pretty. So I'm going to go ahead and just say on this one for our final answer, we're going to round to the nearest pound. Okay. So just like we did in the example one on number 2, round to the nearest pound. Okay. All right. Y'all try those and we'll go over them here in just a minute. All right. So on this first practice problems, it says that two angles are complementary. Oh, and I misspelled two. Two angles are complementary angles if the sum of their measures is 90 degrees. So we're not talking about supplementary angles anymore. We're talking about complementary angles that add up to 90 degrees. If the larger of the two complementary angles is 15 degrees more than 2 times the smaller angle, find the two angles. Okay, so the first thing we know about A and B is that they add up to 90 degrees, right? Then the second sentence here says if the larger one, so looking at our picture, it looks like B is the larger one. The larger one is 15 degrees more than twice or 2 times the smaller one. So, excuse me, 2 times the smaller one would be 2A, and the 15 degrees more than that means we're going to add 15 to it. So we can write this as B is equal to 2A plus 15. So these are our two equations for this system. And because this one's already solved for B, I'm just going to take that and plug it into the first equation for B. So the first equation is A plus B, which again, we're putting in this quantity, right, is equal to 90. And now that we have it substituted in, we have an equation that just has A's in it. So we go ahead and solve for A, which gives us 25 degrees. And then we take that 25 degrees, and there's several ways you can do this, okay? Most of you know if they add up to 90, right, we can just take 90 and subtract 25 to get 65. Or you can take that 25 and plug it back into, you know, either of these and work it out. Either way, your other angle should be 65 degrees. Okay, if you need more time on this one, go ahead and pause the video so you can look it over. If not, let's go ahead and go on to number 2. So on number 2, wait for it. Sorry about the glare on my paper here. Scoop this up. It says Scott's winterizer lawn fertilizer, that's a mouthful, is 22% nitrogen. Schultz's lime with lawn fertilizer is 4% nitrogen. Williams Weaver, owner of Weaver's Nursery, wishes to mix the two fertilizers to make 400 pounds of a special 10% nitrogen mixture for mid-season lawn feeding. How much of each fertilizer should he mix? Now, this one's very similar to the one that I did with the sunflower seeds and the bird seed. Okay, but instead of having a cost for each thing, we have a percentage that it is nitrogen. Okay, so I'm going to call this whole first fertilizer, and you can use X's and Y's. I like to label them because then I know which answer goes with which fertilizer. So Scott's winterizer lawn fertilizer, I'm going to call W, and Schultz's lime with lawn fertilizer, I'm going to call L. Okay. So I know that I want to end up with 400 pounds of fertilizer. So however much I have of this fertilizer plus however much I have of this fertilizer should come out to 400 pounds. So that's going to be my first equation here. W plus L equals 400. Okay. Then I need to make an equation that talks about the percent nitrogen. So I know that W is 22%. And notice here in the hint, it does say to make sure we write our percentages as decimals. So 22% as a decimal is 0.22. So I'm going to do 0.22 times W, because that's my first fertilizer, right? And then I'm going to add that to the percentage of the second fertilizer. So this one's 4% nitrogen. So I'm going to do 0.04 as a decimal for 4% times that second fertilizer amount that we have, okay, equals, now we need a total over here, and it didn't give us a total to put down, right? All it says is that we want to end up with a 10%. So 10% we need to multiply by how much total pounds of fertilizer we have. So we're going to do 10%, which is 0.1 or 0.10, times the 400 pounds we want total. Okay? All right. So now that we have our two equations, you might have solved this by substitution. You might have solved it for W or L and then plugged it in down here. I went ahead and solved it by clearing W. So if I want to make this W the opposite of this W, I need to multiply by a negative 0.22. So I distribute that negative 0.22 to this entire first equation, which gives me negative 0.22W minus 0.22L equals negative 88. And then when I combine down to cancel my W's and solve for L, I get 266.66666666, right? Repeating. So again, we're going to go ahead and round it to the nearest pound. So I'm going to say L, we have approximately 267 pounds of this L fertilizer, which was the second fertilizer, right? So now that we know how much we have of that one, we need to plug that back in to figure out how much we have of this first fertilizer. So I'm going to take my rounded answer for L and plug it into this first equation that I made that says that they total 400 pounds. Okay. So when I plug in my 267, I subtract it, or I mean, if you know it totals 400, you can just do 400 minus 267. Either way, we end up with 133 pounds of that first fertilizer. Okay, so make sure when you label your answers for these, I know there's a worksheet that goes with this section, so make sure that you label your answer in some way. Don't just say 267 and 133. I need to know which one goes with which. Okay, so the 133 was the W. That was my first fertilizer, which was 22% nitrogen. So I need 133 pounds of the 22% fertilizer mixture, right? And then I need 267 of the other one, which was 4%. Okay. And you can label them however you want. If you say 133 pounds of Scott's and 267 pounds of Schultz, that's okay. I just want to make sure you know which answer goes with which unknown value. Okay. All right, so that's 1 and 2. Let's look at number 3. Number 3, we're talking about a taxi driver who's driving to and from the airport, and it's a different price going to the airport as it is coming back, right? It tells us that he had a total number of trips, right, to the airport and back, and it told us a total amount that he earned doing those trips. Okay, so I called the trips to the airport T and the trips from the airport F. So it says a price to the airport is $4.50, from the airport is $11, and we were given two totals, right? We know that he had a total number of 31 trips and he earned a total of $289. So that's where we get these two equations from. The trips to plus the trips from equals a total of 31 trips, right? And then we make one with the cost. So $4.50 times our trips to the airport plus $11 for our trips from the airport equals, and over here I don't have to multiply anything, right? Because they just went ahead and gave me the total cost. So I don't have to calculate anything. Okay, so it's just equal to 289. Okay. All right, so now that I have my two equations, you can solve it however you like. Like I said before, I prefer elimination, so I went ahead and just cleared the one that wasn't a decimal. So I cleared F by multiplying my first equation by negative 11. If you cleared T by multiplying by negative 4.5, that's fine too. Or if you solved this first one for T or F and then plugged it into the second one, that's also okay. Okay, so there's lots of ways to solve this. I just chose to clear F. So when I clear F and solve for T, I got 8. And then you take that 8 and plug it back into one of the equations, and F should give you 23, which means that we had 8 trips to the airport and 23 trips from the airport. Okay? All right, so that is the end of applications of linear equations. I think it was supposed to say systems of two linear equations, but nonetheless. So you do have a worksheet. You have your regular Alta Newton homework assignment for this through Blackboard, right? And then you also have a worksheet, okay? And the worksheet includes both solving systems just algebraically, and a couple of word problems. So if you have any questions, please let me know. Otherwise, we'll see you on the next section.